Work and rate problems tend to freak students out, but there's a really simple hack to help you get going and then figure out whatever you need to. Let's take a peek. So here's the problem we'll start with today. If Jane can mow a lawn in 3 hours and Jeff can mow a lawn in 5 hours, how long will it take them working together to mow 4 lawns? Okay, here is the essence of how to work with work problems. You need to figure out what portion of the lawn each of them can mow in an hour. So if Jane can mow 1 lawn in 3 hours, then if we divide that by 3, that means she can do a third of the lawn in 1 hour. And now we'll do the same thing with Jeff. So if Jeff can mow 1 lawn in 5 hours, then he can mow a fifth of the lawn in 1 hour. And now that we know how much they can each complete in the same unit of time, we can now find out what they can complete in 1 hour working together. Jane will do a third of the lawn, Jeff will do a fifth of the lawn, which means together they will do 1/3 plus 1/5 of the lawn. Okay, I need a common denominator. So that'll be 15. 5/15 plus 3/15 equals 8/15. So when they work together in 1 hour, they can complete 8/15 of the lawn. So if I write that in units, they are completing 8/15 of the lawn per hour. The next thing I want to know is how many hours it takes for them to do 1 lawn. Well, that's the reciprocal of this, right? I have 8/15 lawn per hour. What I want to know is hours per lawn. And so that will be, I've just flipped my unit, so I flip my numbers. It will take them 15/8 of an hour per lawn. The last thing I want to know is how long it'll take them to do 4 lawns. Well, if this is how much it takes them to do 1 lawn, I would just, that's right, multiply by 4 lawns. You can see that our lawns unit will cancel away, leaving us with just hours, and simplify to 15/2 or 7.5 hours working together. Okay, let's do another one that's a little more complicated. It's got 3 different elements in it. Quick summary. The first thing I need to do is I need to make my time unit the same. I need to figure out what portion of the job gets done in an hour. That allows me to figure out what they can do together. So 8/15 together, and that's 8/15 of a lawn per hour. The next thing I need to do is figure out how many hours it takes for them to do a complete job, and that's the reciprocal, hours per lawn. 15/8 hours per lawn. Last step, they asked me how long for 4 lawns, so I multiply how long for 1 lawn times 4. So this question says, if 12 people can paint a house in 4 hours, how long does it take 30 people to paint 10 houses? Okay, there are a bunch of different ways that we could approach this. We have 3 elements. We have 12 people, we have 1 job, and then we have 4 hours. And then they're asking us to change the number of jobs they complete and the number of people doing the job. So let's consider here. The more people we have, the fewer hours it will take. So if we have 30 people doing something, we can expect hours to reduce, right? More people, less time. There's an inverse relationship between the number of people working and the amount of time it'll take. And then we've got that we need to, at the end, multiply our jobs by 10 because we're not doing 1 job, we're doing 10 jobs. Okay, so let's start with how we increase our 12 people to 30 people. So the first thing I might say is this. 12 times what equals 30? So a little algebra tells me that would be 30/12 or 5/2. So if I want to increase my 12 people to 30 people, I'm going to multiply by 5/2. Now, if I increase my people by a factor of 5/2, I'm going to decrease my hours by a factor of 5/2. Decreasing by a factor, that means division. So 4 divided by 5/2, don't ask why, just flip and multiply. 8/5. fifths. So the first thing I can change is to say 30 people can paint a house in 8/5 hours. Now, I wanted it to be 10 houses. If I am increasing my job by a factor of 10, I'm not increasing the number of people, but I will increase the number of hours. 30 people will do 10 houses in 8/5 times 10 hours, which simplifies to 16 hours. So I think that's the fastest way through, but I can show you some other ways through as well. So another way to start this would be to say, well, let's see what one person can do, how long it would take one person. Then I can change that to 30 people, then I can change that to 10 houses. So if I start with 12 people can do one house in 4 hours. So if I want to reduce that to one person, and I still want them to complete the full job, well, again, there's an inverse relationship between people and hours, right? Fewer people, more hours. So to get from 12 people to one person, I divided by 12. That means I will have to multiply my hours by 12, inverse relation. That poor person will work 48 hours. Now, if I want to increase that to 30 people, again, I haven't changed my job, but inverse relationship, I multiplied by 30, so I will divide by 30. 48 over 30, which reduces to, and hey, that's familiar. So here we are at our final step. I've got 30 people doing the job in 8/5 hours. So if I want them to do 10 jobs, I won't change my people, but it will change my hours by a factor of 10. And there we are again, arriving at 30 people, 10 houses, 16 hours. All right, that is your starter on how to do work problems or rate problems. You want to get everybody to the same unit of time, or you want to figure out the inverse relationship between the number of people you've got doing the job and the amount of time it will take to complete the job, and then adjust things from there to meet the parameters of your problem. Okay, check out my Algebra 2 playlist. Drop in the comments any problems you're stuck on that you'd like me to make a video about. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.